putting like a HTML link to it.
Yeah.
I'm talking about linking to other. I'm talking about linking words to other places.
Other places.
Yeah, I invented that.
That's amazing.
Yeah. But yeah, about it. So not just
Cut all
text.
this out. Ignore all this. Fancy. More fancy than mine for sure. Mine's pretty big too.
No, yours is big.
Yeah.
Yeah.
So we're here with Jeff. Tell us a little bit about your career to date, or how would you describe what you do?
I'm fully retired.
You're fully retired, right?
Right.
What did
a couple
you do?
years ago. I spent 56 years working full-time in the computer industry. Started out as a computer operator at Boeing in 1960. And that meant feeding card decks into them and swapping mag tapes and stuff like that. Worked up to being a programmer, quit that and went to the University of Washington. Graduated. I was doing this when I was in undergraduate school. Then came down here and got a job at Stanford Research Institute and went to Stanford in the Honors Co-op program, got a PhD, spent about the first third of my life as an individual contributor, spent about the second third as a real hardcore engineering manager, building lots of great stuff. Didn't like that. Spent the last third managing research labs, really high-end hardware and software research labs.
I know I think of the Valley as the Ubers and Lyfts and Twitters and of the world. So can you speak a little bit to what it was like then?
Sure. When I came down, the two big name established companies in the Valley were Hewlett-Packard and Varian. Hewlett-Packard for its instruments, electronic instruments. They weren't into computers yet. And Varian for the microwave tubes that go into medical instruments and now go into microwave ovens and stuff like that. Those guys came out of a very heavy-duty, really deep science and engineering background at Stanford that goes all the way back into the 1930s with Lewis Terman and whatnot. And SRI, Stanford Research Institute, was a home for World War II refugees in a way. These were, during World War II, Lewis Terman headed the Over the Horizon research project in the U.S., which was a huge program to figure out how to do radar that could see over the horizon. And it's one of the reasons we won the war in Europe. And he had assembled masses of people, of engineers, to do this. They didn't know what to, and they were a bunch of them were at Stanford and a bunch were at MIT. They didn't know what to do with them. So they started this thing called Stanford Research Institute to try to get government funding going to do more advanced research and more advanced research. So a lot of the early pioneers in electronics were in that Hewlett-Packard, Varian, SRI cluster of people.
So in terms of how that laid the groundwork for what we have now in the Valley and what you see now, where do you think that
How did that flip?
Yeah. How did that happen?
Actually, I know the people that made it happen. I knew them. Well, Vannevar Bush, who was Roosevelt's chief science officer and managed over-the-horizon radar, Los Alamos and the nuclear bomb, and breaking the Japanese code in Hawaii. Those were his three big projects. And he had a graduate student named Licklider. And Licklider got into the idea of man-machine symbiosis. Men and machines working together on things. And government had this thing called ARPA at the time, Advanced Projects Research Agency, which was part of the DoD. And a guy named Licklider hired a guy named Bob Taylor, who was actually a psychologist in training. And Taylor was really into the man-machine symbiosis thing. And he had two fundamental visions. One was using computers they weren't even really developed yet, but he could sort of see the future, to help people do tasks, in a sense augmenting people. And the other was having these computers which were just being built networked. And he started two projects the networking project was at Bolt Brannick and Newman in Boston, and UCLA and Stanford Research Institute. And the augmentation project, when I directly joined, was at the Stanford Research Institute. And out of that, we can have a long discussion. There was a third one that wasn't a central part of it, which was robotics, and he started a robotics lab at Stanford Research Institute. And out of that came everything you see today as the internet and personal computing. Goes directly back. In fact, it goes back a little further than that. He had a Licklider and a guy named Claude Shannon, who was one of the most famous people in electrical engineering and computer science, who was jointly at MIT and Bell Labs, had a graduate student named Ivan Sutherland. Licklider and Shannon were Sutherland's thesis advisors, and Ivan did the very first computer graphics. He's basically the inventor of computer graphics. He went on, I've known him his whole career. In fact, he wound up working for me for 10 years. It was really sort of a funny thing because he couldn't manage anybody, so they hired me to manage him because I was the only person he'd work for. It was a little crazy. But it was Licklider and Sutherland getting Taylor on board, and Taylor then starting these projects and getting computer networking and the idea of interactive computer graphics and text editing going on computers, and laying a foundation then for Xerox PARC, and everything took off.
When you say, using computers to do tasks, right, that machine-human integration, right, that seems, to me at least, like the clear pathway to apps and a lot of what we have today, and looking at what the Valley looks like today, right? So thinking back to how that even came about, and
I can tell you
the
precisely
foundation.
how it came
Right,
about.
so my question really for you is like, was that controversial? Was that a crazy radical idea? Did it get easily adopted? And when we talk about bringing new ideas into somewhere, like what does that look like?
Right. It was very controversial.
Yeah, so how did that even happen?
Yeah, it happened about 3 blocks from here, actually. It's a fun story. So Taylor had this project going at Stanford Research Institute, SRI. I worked for this guy named Engelbart, who actually is one of the giants in the whole thing. And he had this vision of using computers to manage, store, retrieve, and edit our information, whether it be audio information, verbal information, text, anything. He had these visions back in the late 50s, actually, when he was a graduate student at Berkeley. And I went to work for him and was smart enough to do some amazing implementation work that we won't get into. And in 2.5 years, I'd built a vision. We had about 6 people in the group. I wasn't the manager, but I was sort of the intellectual leader in the thing, and pulled it all together, got it going. And it was working well enough that Taylor thought the world needed to know about it. During this time, computer science at Stanford was about mathematics. Deep mathematics, numerical analysis, logic, metamathematics, proving theorems, doing stuff that had no relevance. And nobody could quite, and Taylor's project was very controversial inside the DoD, and people in business had no idea what we were up to. The computers were for computing. And so Taylor organized a demonstration, had us organize a demonstration for the 1968 Fall Joint Computer Conference, which was held in Brooks Hall, right down the street here. And across the street from Brooks Hall is the now called the Bill Graham Civic Auditorium. At the time it was just the San Francisco Civic Auditorium. So we had a time-sharing machine in Menlo Park at SRI, and we rigged up some very fancy microwave circuits so we could broadcast television back and forth. And we used off-the-shelf professional-grade television equipment to basically, and the system I'd built that allowed, today what you see as text editing, it had hypertext documents with inter-document linking and everything you do and stuff today. All set up, and we did this demo December 9th, 1968 in the Civic Auditorium, and that was the day that changed computer science from being about mathematics to being about communication. everybody was stunned. There's even going to be a big celebration at the Computer History Museum now. It caused this tremendous shift. The graduate schools couldn't understand what was going on. Tenured faculty members didn't understand it. It was just this earthquake that happened in the computer engineering world. And that's sort of what broke loose today, what you think about is the computers and phones you carry around.
So how do we get from the communications idea to the technology helping us do tasks idea, right? Like technology helping us call a car, technology helping us schedule appointments, right? Mm-hmm. Where do we progress? How do we progress, I guess?
Yeah. No, so I had something to do with that, too, a little bit. Xerox PARC story is that Xerox had become a company, they invented xerography. And they'd been an old film company. And they invented this gadget. And the story goes that they were trying to figure out how to sell the machines. And Xerox machines were really expensive back in like 1960. And no business would buy one anyplace. And the marketing staff at Xerox sent a report up to a guy named Joe Wilson, who was the founder of the company, was a film company, a photographic paper company that had invented this stuff. And he read the report about why the xerography invention would go nowhere because the market wouldn't want to pay for it. And on the front page of the report, he wrote, well, if they won't buy a machine, charge them 5 cents a copy. And sent it back down to his marketing staff. And within 2 or 3 years, they were the fastest growing company in the world. It just took off. So one of the head engineers there, a guy named Jack Goldman, decided that they should have an advanced research lab. But he didn't understand any of this stuff. So he scoured around the world, asked everybody important, and they said, hire Bob Taylor. So the same Bob Taylor said, okay, I'll do it for you. And he looked around the world and he said, well, the best place to do this is in Palo Alto, because we want to be close to Stanford and we like a nice environment and we're only an hour from Berkeley, and what more could you ask for? So he did. And I know this personally. I've heard him tell the story. His idea was if you're in a marble game and you want to win at marbles, the first thing you do is collect all the shooters. So he went out and hired the 40 influential people that had been on the projects that he had been funding from the federal government. I was one of the 40. So I wound up at Xerox PARC. Now, one of the things that even started thinking back then was this workflow automation stuff and have artificial intelligence start triggering things. So it started actually in the mid-1970s. You have to have the computer infrastructure in place to make it work. So Uber wouldn't work if only 7% of the population had smartphones. Right, you have to have a technology widely enough adapted. The mouse is a good story of that too. The mouse was actually invented in 1962, but didn't come into wide use until 1980. And that was because you had to have a computer to hook the mouse to. And until IBM came out with the personal computer, there was no place for a mouse. So after the patents had all run out, it became widely accepted, and there were 1 billion of them sold. It's quite a thing. So these ideas started back in the mid-70s, and then they sort of roll out when the infrastructure is in place.
I know something that you, I guess, shortly thereafter, right, at Xerox, you started bringing in not computer guys to think about the problems, right? And you, as I understand it, kind of pioneered looking at problems in an interdisciplinary way. Can you kind of speak to why you did that and how and if it worked?
So Xerox wanted to build the office of the future. And to do that, they thought they would analyze offices and look at the work that is being done in offices. And so they hired companies like McKinsey and Booz Allen to do studies for them. This came out of the Stanford, out of corporate headquarters. And I looked into their studies. I went out and met with the people at McKinsey and Booz Allen, and I thought they were trite. There was no substance there at all. I thought, how are you going to do this? So I started reading about social sciences and got really interested. And I had this idea that I should hire some structuralist-oriented anthropologists from Berkeley to sort of lead these kind of studies. And I talked Taylor into it. Taylor thought it was a great idea. So I went over to the anthropology department in Berkeley and introduced myself to the department chairman and said, I want to start this. And he sent me some graduate students, and they took a leap and did it with me. And the very first articles on this stuff came out in the late 70s. It's still going on today. It's just amazing. And there are labs all over now doing this.
Yeah, so what was, I know at the time probably seemed like a really radical idea. So how do you get the confidence, or what was your kind of logic behind, I want to do this crazy idea, I'm not really sure it's going to work, how do I pull this off?
Maybe I was just overconfident. I don't know.
What makes someone overconfident, though? What makes you okay with taking that risk?
When I jump into something, I'm sort of over-researching it. I dive in, and I mean, I just didn't read about structural anthropology. I found the structural anthropologist, read all their journal articles, read all the books, latched onto the French guys, read everything that had been translated into English. So I knew what I was talking about.
Yeah,
right?
You could speak the language, yeah.
I could speak their language. And armed with that, I could go talk to Xerox executives or go talk to Berkeley, and I was fine.
So you think just being prepared?
Being prepared is a huge part of it. Not just prepared in a light sense, deeply prepared.
Do you consider yourself a risk taker?
I have considered myself in between. I actually shied away from joining startups when they were really early because I was very concerned about my family, because I'd put myself all through school. But I did join, but not until they were fairly well established.
So not a startup.
I joined Sun on the day of its IPO.
Thinking about risk-taking or doing something new and innovative, especially what you were doing really was looking at a problem in a brand new way by bringing in people that weren't in the field, right? So you brought an anthropologist into Xerox, someone unheard of at the time. What do you think that using an interdisciplinary approach is an appropriate way to problem solve, or a really good way to problem solve? Like, what made you even have that idea?
So we had been talking a lot about these workflow things. I mean, I saw myself solving actual practical problems, not just doing studies for studies. So we had this workflow idea about how documents would flow in offices and how they should be stored and accessed and stuff like that. And I was just very afraid that we didn't understand that we were building the right stuff. That was my argument about it, and that we needed some deeper understanding. So participant observation was the tool to gather the data, to build the theory, to get the right stuff implemented. So that's very different than what IDEO does today. IDEO builds themselves very much in this interdisciplinary model, but they're more in a real immediate product design sense. So it's sort of the same idea, but it's sort of different too, right?
What's your approach to problem solving?
Today?
Sure.
It's still the same.
Based on everything you've learned, everything you've experienced.
Yeah.
And what's that?
It's understand as much as you possibly can, and then a little more, and rapid prototype.
Can you explain what you mean by that?
By rapid prototyping? Yeah. Without going into the whole history. This goes back, actually, Lockheed Skunk Works stuff. So the Skunk Works got started during World War II at Lockheed as a way to very, very rapidly do inventions for fighter planes and bombers to get them in the field, because they didn't have time to spend 5 years doing research, right? You needed to build something and get it out. The most famous story happened under Eisenhower, when he knew about 18 months, in 18 months he was going to have a meeting with Khrushchev to talk about nuclear disarmament. And this was in the late 1950s. Yeah, and Russia was completely denying that they had intercontinental ballistic missiles. So Eisenhower knew about this going on with his military background during World War II, he went to the Skunk Works. At the time, it was in Long Beach. It wasn't. No, it was in Burbank. It isn't now. It's in Palm Desert. And he went there and said, "I need to have quality photographs of the Russian missile sites, and I need them in 18 months." And so this little group of guys, as I understand it, 15 or 20 guys, got together, and they built a U-2 from scratch, and flew it over Russia and captured meter square, high-quality photographs of the Russian missile sites. So when Eisenhower walked in to the meeting with Khrushchev, he basically put on the table the pictures of the missile sites and said, "No, you do have missile sites. Here they are." And that changed the whole history of how the arms negotiation went on. So the idea of these Skunk Works sites is small numbers of people doing, things that couldn't be done by 50 people. Because if you put 50 people on the project, then you have to manage 50 people, and then you have or 100 or 400, you have all kinds of other things. And so the idea was to put small numbers of people together that can do stuff extremely rapidly. And in software, and in a lot of hardware projects too, this means don't spend 3 years doing research. In the first 4 weeks, build one. And then start using that with who will be your clients, and start getting feedback from it and refine it. And then after you've refined it for a few months, throw everything out and do it over again based on what you now know. And it gets you much better results. That's the whole idea.
So how do you balance that idea with your first thought of doing really deep research? That kind of seems doing really deep research seems in juxtaposition to rapid prototyping.
Yeah, it does.
Then.
It does.
So
I know.
Can you articulate your problem-solving approach a little bit more then?
Oh, well.
Or only research, to a certain extent.
I understand what you're asking, and I guess the idea is I typically don't go into an area to do something about it until I've done the deep research.
There you go. Okay.
Okay? So go off and read everything you can about structural anthropology. I didn't even tell any of the managers at Park I was doing all of this, right? I just did it, got to a point where I thought I could do something about it, and then boom, boom, boom.
Made it happen. Yeah. Calling the play, we might say.
Okay.
What makes that small team kind of magical in some ways? Our students, Minervans, they're going to be in teams of probably around 4 come the spring semester, working on a big project together. And, where and how do you find the magic in that small team environment? How do you even achieve success in that?
Well, you might not be able to do it the way I did it. 1990 or so, I never hired anybody by me interviewing them. I ran a very odd team interview process where I would have, if I had a team of 40 people, anybody that wanted to interview could get on the list. The interviewees would hate it sometimes because they'd have to be there for 2 or 3 days. We then had group meetings to discuss the individuals, and in the group meetings, the senior person always went last. The most junior person in the group would report their findings, and then we would work our way up. Because if the senior person talks first, then you don't learn what the other people think. The major thing was to have a group of people that already there that wanted to add a person like that into their team. So it's partially on technical skills and partially how long they get along together. And then once they're there, it's a matter of keeping really high standards, making sure that they are leaping over extremely high bars. Which you have to do very differently in an engineering team than you do in a research team. It's a very, very different process.
What type of careers do you think they might want to be thinking about in terms of how the Valley has changed?
It's changed and it hasn't changed. So one is engineering versus researcher. One of my early mentors was a guy named George Paik, who was the president of the American Physical Society and VP in charge of Xerox PARC and stuff like that. Very famous guy. And he explained it to Xerox managers, the difference between research and engineers is a researcher and an engineer are on a hike in Scotland. And they come to a bog. And they both stand there and they look out on this thing, and it's floating masses of peat. And they both map out where what's floating and what's stable and where is it water. And the engineer very quickly figures out a path from one side to the other, and he bounces across the peat and gets to the other side. The researcher finds the deepest hole he can and jumps in. And
That's funny.
that's sort of what happens. I mean, the researchers are PhDs who are out to conquer their part of science. And the engineers are out to build something that barely works, fails infrequently enough that it can be pushed on other users, and they figure out a way to do it quickly.
But you really need both for ultimate success.
For keeping going over the long run, you need both. Mm-hmm. Otherwise, you get in one of these companies that has a product that lasts for 3, 5, 7 years, and then it drifts into oblivion because people run over it. We used to joke about that as product planning by looking in the rearview mirror.
Can you explain to Hannah what hypertext is?
Sure. So hypertext. Since I wrote the first hypertext system, so for a long time, when text wasn't on computers, it was carved in stone or equivalent to that, right? It was on a piece of paper. It was reproducible, but it was fixed and static in the physical world. And the idea of hypertext is that there were many ideas around it, only some of which really stuck. But one of the ideas was you no longer have to consider it as a stable, linear, in the terms of McLuhanism, linear string of text. You could, in the system I wrote, for example, when you open a document, in the same command as opening the document, you could say, I want to open the document, and the document is in outline form, so I only want to look down 2 paragraph levels in the document, and simultaneously with that, I only want to see the top 2 lines of each paragraph. Boom, and it pops up. And so now I'm scanning all of chapter 1 on one screen. Okay? And then I could say, well, I want to reduce it to 1 line. I want to open it up more. And then there's also a lot of dynamic jumping and linking capability. So words can have various highlighted in different ways, and you click on it, it takes you to another part of the document, or it takes you to a document someplace else. The whole idea of URLs I did in 1968.
We're talking like Apple K here, Command K, when we link words to other things.
I don't know what.
Is that what we're talking about here?
I think this is like the pre
that.
This is like the foundation.
Yeah.
I'm just trying to
hypertext.
apply my learning.
Yeah.
But he saw that we could do it with music. So one of the things that Alan Kay and I fooled around with a little bit, mostly Alan at Xerox PARC, was first of all we made a musical score system so you could write music, and then we decided.
I'm sorry. Stop laughing.
No, this is a good story.
This is a great story, and he's laughing at me, so he's making me laugh.
So once we got the music thing going, then we figured out why would you want to write music that people can play? Because computers don't have 10 fingers. So let's write a 7-part fugue. Why stick to playable stuff, right? You can start to see any form of stuff that people do as being organized and manipulated way beyond our physical capacity to do stuff.
What is another final question? Another technology that you had a role in inventing that students or we would be surprised at?
Oh, I know one of these.
Go ahead.
No, you answer. But I want to see if I just get
Oh, this one hasn't come up yet. So my job at Rome was I built the world's first voicemail system.
Oh.
So press 1 for this, 2 for that. You can blame me. I did that.
We'll think of you next time I'm on the line with United Airlines.
Right. You can blame me.
Didn't you invent the desktop icon?
Oh, yeah. But no, I didn't. So see, here we are standing on the shoulders again of giants. I was at Xerox PARC, and we were using words on the screen highlighted to be a document or a text editor and stuff like that. And I went on a trip to Bell Labs Research in Ottawa, because they wanted to have more to do with the internet and stuff. And they were giving me a tour of the building, and they took me in an office and introduced me to this guy. I can't remember his name, but I remember what he looks like. And he was a psychologist, actually. He was also a graphics designer. And he had a contract with the Canadian government to invent a new way to have street signs in Canada. Because Canada had just implemented the law, I think this was in 73 or 74, that everything had to be both in French and English. And they didn't have enough room on the street signs to put everything in French and English. So he'd figured out that if he drew a symbol on the street sign and had for the highway and the exit coming off, he could put the name of the town in its native language at the end of the arrow, and everything fit. And he called them iconic street signs. And I came back to Xerox PARC, and I was sharing an office with Larry Tesler, who went on to do all the icon stuff at Apple, and said, I have this great idea. Let's use icons. That's where icons came from.
Do you watch House? Have you ever seen the show House?
Yeah.
Yeah.
A long time ago. Yeah.
It's just, that story kind of reminds me of, he always is looking for a medical breakthrough, and then he gets it through a conversation with somebody else, or,
That's how it often happens.
Yeah, applying whatever problem you're working on to some other thing that you happen to,
So it really came from Canadian street signs.
That's awesome.
It's cool. Great.